Hello everyone. So today we will be solving one more interesting problem to 79 perfect squares, and the problem says given an integer n, return the least number of perfect squares that sum to n. Okay, so we are given one input value of n is equals to 12, and we have to tell that least number of perfect squares that can be reachable to 12 using these perfect squares. Okay, so we are here somewhere in f of 12, and we need to reach using the squares. Okay, so what we can do is we can start subtracting all the values of the numbers from 1 to 12, and we see like which number gives us the minimum number of perfect square that sums to n. So if we start from 1, then this would be the way of reaching using 1 square, right? And this would be the number of ways using 2 squares, and again this would be from 2 squares minus 2, and from 3 became, then f would be minus 12 minus 3 square, and we cannot go beyond value which becomes negative, so we would be pruning this branch. So if I'm here, f of 12 minus 4 square, which is 16, and we won't be entertaining the negative values. So we have found our upper limit for the problem. So this is going to be pruned. We don't need solution. So these are our j values. These are our j, and this is our n basically. And what we want, we observed like j square is less than equals to n, and j starts from 1. Okay, and out of all these paths, so again this will become f of 11, and we will be finding the number of ways that perfect square sums to 11. Similarly for this, f of 10, f of 12 minus 4 is 8, so f of 8, and then it would be f of 3, and so on, and we need to find the number of ways. Again, it would again branch it out into it ways all 3 ways, minus 1, minus 2 squares, and minus 3 squares. Similarly from here, so we'll be starting from the below. So the base case for our problem would be f of 0 is 0, and f of 3 is again so. And one thing we observed, like from here, if you want to reach here, we need to add 1. That would be one step if we are going from these all levels to the next level. So, and after all these, we need to find the minimum, which is the minimum number of squares required to reach to the square number n. And this is our base case, and we have our constraint. We found our constraint as well, and the only thing left for us to solve this problem is write it down. So here is how we can write it down. I'm going to use the top down bottom up DP approach. So we'll define one DP array, which will have all the, no, we'll say let dp of I is the least number of perfect squares, um, perfect squares to sum to n, to sum to I, and we'll initially define our I to be a maximum infinity, just one regular infinity. We'll fill all the values in our dp array of size n to be infinity so that the comparison becomes easy every time. So this is, and we are having up to n plus 1 because we will be at the end we will be returning the last number, which is the number of ways to return. And the base case for our problem was dp of zeros is 0 because the number of ways, the least number of perfect square that sum to 0 is 0. And for we'll starting from 1 and we are going up to n plus 1, which I showed earlier. So this is the first loop, and the another which our j constraint was j was from 1 and it will go up to n plus up to n, j square will, so we'll be checking for j square is less than equals to n, and if we have found that, then we would say that give me the next value, which would be the minimum of dp of I, the current value, and all the paths that you have explored till now. And the one is basically the number of ways from current to next state. So this is this, and we will be incrementing our j, and yes, this is what we need to return, and let's see what our dp comes out to be. And let's print it out and see. Okay, so you can see the number of ways, the least number perfect square that sums to 0 is 0. The least number perfect square that sums to 1 is 1. The number perfect square that sums to 2 is also 2. And 3 is 3. So if I take a one small example, like say we are at f of 6 and we need to find the number of ways to reach to that's perfect square that sums to 6. So we'd be starting one branch from 1, 2, and we won't be going till 3. So this is f of 6 minus 1. This is f of 6 minus 2 square. So now we need to find the value of f of 5, and here we need to find the value of f of 2, right? So we're exploring this branch and we have only one path, so that is f of 2 minus 1 square, which is nothing but f of 1, and then we need to find f of 0. From 1 we need to find, we'll be starting from f of 0. So f of 0, the number of ways for 0 was 0. Then we'll be reaching to f of 1, and f of 1 has one way. So f of 1 is 1, and we will be summing that with our f of 2 next time when we reach out, like f of 1 plus this one, because from here when we will be going back to when we will be finding the f of 2, so what we'll be doing is we are doing f of 1 plus 1. So the number of ways from here comes out to be 2, and from here when we go over above is f of this is f of 2 plus 1, and f of 2 is 2, so number of ways from here it comes out to be 3. And let's explore our f of 5. So f of 5 has 2 ways, 1 and f of 5 minus 1 square, and f of 5 minus 2 square. F of 5 minus 2 square is 1, and we knew that from 1 the number of ways that comes out to be is f of 1, and from f of 4 we need to explore, but we know the minimum number of ways, so the result of this tree whole would be f of minimum of all these tree would be 1. So this is 1, so f of 5 minimum way would be 1, and plus 1 we need from here to reach to the next level, so that is nothing but f of 5 is equals to f of 1, minimum value is 1, 1 plus 1 2, so which we have also observed, which we can observe from here, that to find the value 5 we have 2, and once we are here, the number of ways, all we need to do is we need to again compute the minimum from both of these, and add 1 to that, so that is nothing but the 3, and that's how we, so for whatever the minimum that we have computed here, so the minimum that we computed actually over here was 2, and this is the value of basically f of 5, because this is 2 and the minimum of 2 and 3 is 2, and from here we need to go to one level above, which is 2 plus 1, so the number of ways for that, the number of perfect square that sums to 6 is 2 plus 1, which came from f of actually 5 plus 1 is equals to 2 plus 1, which is 3, and this is what we are returning using the DP array. We can see that this is evident over here as well. So yeah, that's how you solve this problem. Let's run our example test cases and see how our let's submit and see how our problem, how our algorithm performed. Okay, it's pretty good, and the time complexity for this is O of n square root of n, and the space complexity we are using is O of n. Right, so that's how you solve this problem. Thank you.